Hi, this is Akshata. I am a second year master's student at UPenn. I am doing my master's in nanotechnology, and I am here at the ESRF, which is the European Synchrotron Radiation Facility, to carry out my research, which includes imaging of platinum nanoparticles using the BCDI technique, which is the Bragg coherent diffractive imaging technique. And I will be explaining it to you how the synchrotron works, what are the instrumentations that go into the system, as well as the data analysis part. Synchrotron radiation describes radiation from charged particles accelerated to relativistic speeds along curved trajectories. The application of uniform magnetic field perpendicularly to the orbital plane forces the relativistic electrons to travel in closed circular paths, leading to radiation emission or X-rays governed by the Lorentz force. Here, as you can see, I am on top of the synchrotron, and this is the chamber under which the electrons are accelerated using the system of magnetic fields. There are different beam lines that come out of the synchrotron, and this is the ID01 beam line. This is the optic system that is used to focus the X-rays. Light of a particular wavelength is filtered out and is then made incident on the sample that is mounted on a nanopositioner. So you can see the nanopositioner here, which have hexapods. This is where the sample is mounted. Nanobeam aim to probe the smallest materials or to image materials in scanning probe mode. The diffraction patterns are obtained using the 2D detector. You can see the 2D detector here, and this is the platform where the 2D detector is rotated. And instead of using lenses for this system, computers are used to image the nanocrystals, and different softwares are used to position and to control these systems as well as obtain the images. The data treatment is done using the Python BCDI package as well as Finex. Here you can see this is the diffraction pattern of the crystal. Masking of this data is done so as to remove these extra signals that is not required. And then the data is pre-processed, as well as the phase retrieval is done using the Jupyter notebook. Here you can see we can put in different parameters such as the detector parameters, the setup, and various other settings. The phase retrieval is done in the Jupyter notebook, and as we can see, this is the phase retrieval, and we can get an idea about the structure of the crystal and its different facets. And finally, this is what a crystal looks like. We can also see the different dislocations of the crystal and hence get information about its coordination number, the stress on different parts, the structure of the crystal, and other information.